Okay, guys, we're getting started. So the first problem, I don't have an answer key for this, by the way, so I'm just going to do the answers with you guys. I'm going to do each one with you guys. So there's 6 problems I assigned, 30, 31, 33, 34, and was it 36, 37? Is that correct?
Yes.
Okay, so let's go through each of these one by one. So 2 plus 3 sine x, right? So if I do 2 plus 3 sine x, okay, question? No? All right. So guys, quiet, please. So what you want to do is figure out where you would start and end this graph. Because you have plain old x, it's going to start at 0 and 2 pi, right? So I start and end at 0 and 2 pi. And I'll partition 3 ways, right? So that's pi, and you know what the other ones are. Now, the vertical shift, or the k value, is 2, so I have to bump up to 2. A is 3, of course, right? So I have to go 3 up and 3 down. So I'll do 3 more tick marks above, and then down below, I'll do a little dashed line. I like to do that. Down below, I'll put let me get rid of that 0. It's a little distracting. And also do this right here. We'll go green for the actual curve. So you can start a sine, right? So it's going to start here and end right here. And remember, you go high, so middle, high, middle, low, and back to middle. And there you go. There's a graph. So it should be very, very straightforward. So that's y equals 2 plus 3 sine x. And that's the process I would use to do that. And I'm recording so you guys can watch it if you like. Next up is negative 3 minus cos 4x. So negative 3 minus cos 4x. My short-term memory is terrible. Did I get that right? Okay, good. All right. Okay, so I'd actually just rewrite like this just for now. I always like to put the cosine first. Okay, so we'll do our graph like this. And I'm kind of adjusting it because I know I'm going to be going below the x-axis and I'm going to be shifting 3 down. So my k is definitely negative 3. My amplitude, but the amplitude, well, a is negative 1, of course. But the amplitude is 1 because the absolute value. But it means I'm going to be starting below. So 1, 2, 3. And because I'm going to go 1 up and 1 down, I put an extra tick mark right below negative 3. So that's negative 3, of course. Starting and ending. So 4x equals 0. So x equals 0. So obviously, because there's no horizontal shift or phase shift. But then also 4x equals 2 pi, because the period is going to be 2 pi over b, or pi over 2. So I'll put pi over 2 here. Even though it's not quite the scale from the previous graph, I don't care. You know, just make sure you have enough space so you can see the graph. So I'll call this pi over 2. That'll be analyzing what tick marks are going between. So you have to do 3 partitions, right? What's halfway between pi, sorry, 0 and pi over 2? Pi over 4, and they have 2 more partitions, would be pi over 8 and 3 pi over 8, if you were to label them. Actually, I will ask you to label them. I'm just not going to do it here because I don't have enough space. And then now the midline's here. That's kind of the middle of the graph. Now you're going 1 up and 1 down. However, it's a negative, it's a reflection. So you're not, it's cosine. So sine starts at the middle, right? But cosine starts at the peak. But there's a caveat. You got to start below the midline because it's negative, right? So you got to start here. And if it helps, plug in 0, see what happens. Cosine of 0 is 0. But sorry, cosine of 0 is 1. Negative 1 minus 3 is negative 4. So if it helps, plug in a number. And then you just know the pattern, right? Here we go. That's it. Easy peasy, right? Okay, we're cool. All right, so the next 2 are going to be a little more challenging. 1 minus cos 4. Okay. See if I can toggle back and forth. Actually, let's not go. Oh, it's sure work. All right, thanks, Oscar. All right. Yes, my short-term memory stinks. All right, so here we go. We have y equals, this is number 33, right? Y equals, I'm going to write negative 4 first. Negative 4 cos pi. It's nice that's the right factor for us. And then plus 1. Okay. I'll be bronze again. All right. So in this case, my a value is negative 4. My k is 1. So I'm being incredibly consistent here at how I'm going about this. So k is 1. So I have 1. Oh, Brooke, go ahead.
Wouldn't
I feel like amps can always be positive.
You're right. I'm just giving the a value.
Okay.
The amplitude is 4, totally. But I'm just giving the a value to remind me that I have to flip. That's all. But yes, absolutely, you gotta say the amplitude is 4.
If I said A is positive 4, would that?
Well, put it this way, just to make my life easier when I grade this, I'll put a table next to a question like this, and you fill up the table and say, what is the amplitude? And so you write 4.
Okay,
Yeah. So, and that's what I would look at. Because when I don't have my test structured as nicely, then it becomes kind of a messy way to grade. And then I have to be somewhat more lenient with how I grade it. So, which I know being lenient is good, but all right. Anyway, you're going up to 5 and down to -3 because you're going 4 higher and 4 lower than the midline. So we'll do this. Okay, we have to shift it 3 left. Our h is -3, of course, right? So I'll put, and then let's figure out the starting and ending because the period's totally going to be 2 pi over b. Yes, Oliver, go ahead.
You had h is -3, even though in the equation it's +3. When I was doing this, I just wrote like period shift is 3 left. How
Sure.
do you want us to write that?
Same thing, or -3, it's fine. Yeah. Okay, so actually, I kind of goofed a little bit because I really need to focus on the left side of the y-axis, but that's okay. Let's do -1, -2, and negative. So I'm gonna make it kind of tiny. Not ideal, but it's okay. And if you could do the whole start and end thing again, right? Pi over x plus 3 equals 0. So x would have to be -3. And then pi x plus 3 equals 2 pi. So x plus 3 equals 2. X equals -1. So I know I did this last time we met, but personally, the more I think about it, if you can identify h, right, which is -3, and identify it here, which is 2 pi over b, b is pi, so 2 pi over pi is 2. You kind of know where starting ending without doing stuff in black. I just did this as a crutch if you guys find it helpful. But really, once you get strong mastery of this, it starts at -3 and it's going to end at 2 away. What's 2 away from -3?
Negative.
Exactly. And then you partition. And actually, I should have partitioned a bit more. But I'm not going to write them because it's getting kind of crowded. And then it's cosine, and it's got to start below. It's got to start below. So it's going to start at -3. And just to be sure, plug in -3. -3 plus 3 is 0. Pi times 0 is 0. Cosine 0 is 1. -4 times 1 plus 1, -3. So I feel good about it. And then we know it goes to the middle. Goes to the peak at 5, all the way up to 5. Down below here, and down below here. It's going to be kind of skinny. Now, if you decide to, I like the sound effects, thanks. Now, if you decide to space it out more, like we have like the negative side of the x-axis like fully expanded, and you space these out more, that's cool too. I don't care. You space however you want. But the numbers matter, right? You gotta make sure the numbers are good. Okay, then Unamas, let's look here. 2 plus 4 sine. So let me clear. So it's 34. Y equals 2 plus 4 sine. And short-term memory stinks here. Let's see. Sine, so 2x plus pi over 6. So 2x plus pi over 6. Okay. So I'll just write like this first, y equals, so it helps to rewrite a little bit. Factor out the 2. If you factor out the 2, what do you think the inside's going to be now? X plus what? Yeah, pi over 12 because you're dividing by 2. So it's kind of weird. That's not a nice number, but we're going to deal with it. So I have to shift pi over 12 to the left. Okay. What did I just do? Here we go. Yeah, go ahead. Sure, yeah, totally. Yep, absolutely. So I'm going to put negative pi over 12 here. And your period's going to be 2 pi over b, or 2 pi over 2, which is 1. Sorry, 1 pi. So what's pi added to negative pi over 12? Yeah, so, and then, again, it's not totally scale, so we'll just kind of go with it. 11 pi over 12. The midline's at 2. You have to go 4 higher. 1, 2, 3, 4. So go up to 6 and down to -2. Okay, so we're okay there so far? Okay, good. Okay, what's halfway between -π/12 and 11π/12? It's gonna be 5π/12, right? What's half between 5π/12 and 11π/12? 8π/12, which would reduce to 2π/3. And what's halfway between -π/12 and 5π/12 should be 2π/12, which is π/6. Again, totally not to scale. I know it's getting really crowded. We'll go with it. You got your midline. It is sine, so it's going to start in the middle. And it starts here. And it's going to go up and down or down and up? Up, yeah. Up and down. So here, 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 and here. And there you go. There's your graph. So hopefully you guys feel more comfortable with the graphs. Feels good, yeah. Then the other side, let's write the equations. Let's make sure we're good with that. And I did make a video that kind of talks about writing the equations. Hopefully you guys watch it. If you didn't, that's okay, because I'm talking about it anyway. But you have the resource there. And by the way, if you go to Schoology, you'll see a playlist right here. This has all the videos I made for the unit. So if you ever need to go back and watch, I label them appropriately. So, and once you watch, you kind of know where in the notes by the page number what you see there. So anyway, let's look at the other problems here. Actually, I'll do it on the sheet here itself. Hold on, let's share full screen. There we go. Okay, now I'll probably be a little more explicit on a test or homework quiz. And again, I don't have a homework quiz prepared yet. We'll get to homework quizzes tomorrow. By tomorrow, we'll start doing homework quizzes. I would probably be a little more explicit. Say, hey, let's make A positive. Let's make H negative or whatnot. So I want you guys to think more critically about stuff. But for now, let's make A positive. So A is bigger than 0. And we'll make H positive also. What the heck? Actually, no. H will be a free for all. All right. What's the amplitude here, by the way, guys? 3. So A equals 3. Period. So how long does it travel one cycle? So what is B going to equal then? So we're halfway there. Is there a vertical shift? So K equals 0. And H equals π/6. Actually, yes. No, it's π/6. Yeah, we're gonna make it π/6. So yeah, right. This is for sine. Yeah, we're doing sine. It does depend, right? We're doing sine right now because I want to start in the middle. So I'm gonna say y equals 3 times sine bracket 2x minus π/6. We're gonna π/6 to the right, and that's it. If I plug in π/6, I should get 0. I trust I did it right. So there you go. That's you just send that for cosine. Everything stays the same except for the h value, right? Now cosine, I'm gonna start at the peak. Now this one's kind of not a fun cosine one to do, but here's what you can do. If I distribute the 2, that becomes 2x minus π/3. Remember I said it's gonna be shifted by π/2. So if I do this math in my head, it's always never a fun problem to do in your head. Give me a sec here. I think you should get x. Actually, you're gonna do this.
Did you use the partitions of the sine graph?
Not well. Actually, you know what?
To go in the middle.
You know what? Actually, I like Oliver's idea better. Yeah, I'm overcomplicated, guys. Let's listen to Oliver. So, what's halfway between π/6 and π/6? 4 π/6x, right? Halfway between π/6 and π/6. We're good with that? Okay. So now if you have π/6, which is 2 π/12. You have 4 π/6, which is 8 π/12. What's halfway between 2 π/12 and 8 π/12? Yeah, 5 π/12. So it's gonna be x minus 5 π/12. Yeah, actually, I like that idea better, the way Oliver reasoned it. So that's what I would do. Look at the partitions. Yeah. Yeah, you could have done it differently. Sure. You could have gone to the left. Because I didn't specify what H had to be. So is that okay? That works? All right. And the last one, 37. We'll do this one more quickly. What's A here, guys, for 37? A is 2. K is also 2. Period looks like it's going to be 1, 2, 3, 4. So the period's 4. So 2 pi over b equals 4. B has to be 1/2. No, pi over 2. Yeah, b is pi over 2. So y equals 2 sine. Actually, do the cosine first. Because there's no phase shift for cosine. H is 0 if we do this for cosine. So 2 cosine bracket pi over 2 x and the bracket, then you need bracket parentheses been fine, plus 2. And then sine, let's say I start the sine over here. So y equals 2 sine bracket pi over 2. And then I'm going to put inside the parentheses, x minus y. 3 bracket plus 2. Yeah, so there you go. Now, if I started h over here, then a would have been negative, right? Negative 2. It would have been negative 2 if I start a over there. Sorry, h over there. So, and if you did, that's fine. I won't fault you for that. That's totally fine. Okay, we're okay? We're good? All right. Okay, so that's a very thorough homework review. Now let's get to the notes. And what we're going to do is we're going to pick up where the video left off. If you have any questions, let me know. Duke, you have a question? Go ahead. Yeah, go ahead, please. Yeah, that's what the yeah. So that's if you didn't factor out. I would prefer you factor out. They'll make your life easier. But if you didn't factor out, then that's what you'd have to do. It's the same thing.
Oh, but it's not saying like negative C over B and C over B are the 2 endpoints of like F.
Yes, right.
Depends on if it's minus C.
Yeah, it depends on, it's like
Right, and it'll take care of itself. Hold on, we'd have to wear a page. Yeah, right here, part 4. Yeah, let me pull up my
it's either or, not both.
Yeah. Right.
You found your value to be over C.
Actually, let me make an addendum to those notes. I actually misunderstood that question, guys. Sorry, that was confusing. I think what I meant to say was where it starts and ends, but really what you're going to do is going to set this equal to 0 and 2 pi. So, guys, my apologies. Yeah, sorry about that. I didn't read it carefully. I thought I was asking what were the specific endpoints for the x-coordinate endpoints. I didn't read it correctly. It would be. You said equal to 0, you said equal to 2 pi. Yes, it could be negative C over B once you solve it, or positive C over B once you solve it, right? Yeah, my apologies. That was confusing. Yeah, thank you for clarifying that, because I didn't read this carefully. I kind of glossed over solving the equation. So what are you going to set this equal to? 0 and 2 pi. My apologies. So if you were to actually solve it, Bx would equal, depending what that is, right? But I don't know. It could be C or negative C, right? I have no idea. And then this one would be Bx equals 2 pi plus minus C, divided by B after that. Yeah, my apologies. I didn't do that. And that kind of makes sense because that's 2 pi over B, which is the period, plus minus C over B, starting point.
Yeah.
Yeah. So hope that clarifies it. We're good. Okay. I think we can move on to part 4. All right. And just in interest of time, let me look at how we're looking here. It's also a weird schedule. Okay, so we got 11:35. So we got see how much we squeeze in 30 plus minutes or 35 plus minutes. All right, here we go, guys. Okay, so we're going to talk about secant, cosecant, tangent, cotangent graphs. We're going to talk about them in general. We're going to generalize all 4 of those for sure. I think I could do that, and we'll see if we could do the different transformations. I think I can get this done. I'm confident we can. All right. let's get moving. Okay, cosecant. Cosecant, as you know, is 1 over sine, right? So cosecant theta is 1 over sine theta. We know this, right? So let's fill out this table here. Sine, again, that's going to be 0 and 0 and 0, right? And that's going to be 1 and -1. We're okay with that so far? And if I do the reciprocals, undefined, 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 1 and -1. So far, so good. Okay. Pi over 4, that's root 2 over 2. 3 pi over 4 is still root 2 over 2. 5 pi over 4 is negative root 2 over 2 and negative root 2 over 2. And then you flip these guys. When you flip them, I'm going to do this instead. You can write 2 over root 2 if you want. But at this point, it's kind of good to rationalize a little bit because 2 over root 2 seems kind of weird. Because when you flip 2 over root 2, if you rationalize the denominator, you want to gain 2 root 2 over 2, which reduces to root 2. And does anyone know what root 2 would be roughly as a decimal? 1 point what? 1.414. Thanks. Yeah, sorry, Catherine. Yeah, that makes sense, right? So yeah, totally makes sense. I know we have 2 Kates in here, so I get confused. All right, so anyway, yeah, so let's do this. Let's go and do the plot. Okay, let me move this because this would be nice to have. One. And let's see if it lines up. It kind of doesn't line up. That's okay. I'll just put it off to the side here. Actually, you know what? I'll just clear this darn screen. I got my reference right here. Okay, let's plot the points. You guys have right in front of you, I just don't. So you got 0. And that's 0. And that's 0. And then you have you have asymptote. Gosh darn it, sorry. Actually, let's do sine first. Sorry guys. Let's do sine in blue. Let's graph sine. We should. So y equals, let's graph sine first. So I'll do in blue. So here, 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 there, and there. Okay, so there's sine, right? We're okay with that? So y equals cosecant theta. I'll do that in red. Now, wherever you have an x-intercept, if you don't have a vertical shift, or wherever it crosses the midline, because the midline's at y equals 0, you're going to be doing vertical asymptotes. They're vertical asymptotes here. There's a deeper reason why. For now, we're just going to go with the fact that A, you're dividing by 0. But the deeper reason is that as x gets closer to one of those asymptotes, y is getting going towards positive. Like, for example, if x were like 3.1111, whatever, 3.1333339, it's awfully close to pi. What's going to happen is you're doing 1 over a tiny number, right? You're doing 1 over sine, right? And that makes the number really big. That's really what's happening if you were to plug in, like, for example, let me get my calculator out, right? Let's switch to radian mode. Yep, I'm radian mode. So I know sine pi is 0, right? Duh. But if I do sine of, like, say, 3.133339, it's kind of tiny, right? And if I do 1 divided by that number, it's 121, right? So like I'm really close here, up there. So that's the main reason why we have asymptotes. Not just the fact that it's undefined or you divide by 0 at those locations. It's because they get closer. It's kind of about, it gives the concept of a limit, which we'll talk about in the spring. We'll talk about limits down the road. So what you're going to do is that, I mean, you could plot the points if you want. I'll do it in green. Sorry, I'll do it in red. We did red. So definitely this is still 1, and that's still -1. And this is root 2, which is about 1.414, and that's root 2. And that was negative root 2 and negative root 2. But really what's happening is that it's going to go against the asymptotes. The asymptotes kind of guide the graph. And that's how you do it. So use the sign as a foundation, and you go against it. And yet asymptotes in the middle. We'll work the graph across the middle. The domain and range obviously will be different compared to sine. Question how I made that graph? You guys did this last year, yes or no?
Yeah.
Okay, good. Okay, good. I'm glad you guys got there. There have been some years where I didn't quite get this in Algebra 2 trig honors when I taught that class, but glad you guys got it. So the domain's all real, except, actually, let me take it back. So you could say, this one's kind of weird, guys. Quiet, please. Where were the asymptotes again? Every pi units, right? So you could say that. K pi or pi k, whatever. Yeah, actually, I like pi k. That sounds better. And where k is any integer, or the set of all integers. The range is not all real. There's a gap between what and what? -1 and 1. So you got to write like this. Vertical asymptotes will be x equals pi k. Again, k is any integer. Symmetry does have symmetry. It's odd, just like sine. And the period's still 2 pi. Unless you shift it or you adjust it. Okay, we're good? Cool. Okay. Let's move on to secant. Secant. Just to jog your memory. Let's just really quickly here. So this is 1, -1, 1, 0, 0, √2/2, but -√2/2 in the second quadrant, -√2/2 in the third quadrant, which explains the even symmetry, and then +√2/2 here. Then 1, -1, 1, undefined, undefined, √2, -√2, -√2, and √2. So unit circle, right? It's a lot of unit circle stuff too. Okay. Does that make sense, the table? Okay, I'll give you guys a moment to copy that down, then we'll do the graph. Good? Cool. All right, let's move on. Let's do the graph now. So we do the graph. Again, I'm going to do cosine in, we'll do cosine in green. So it stands out. And I'll do the, well, we'll use pink. Secant will be in pink. Okay, so cosine graph, I know it looks like this. We hit the peak. Whoa, let me do turquoise, light blue. So we have this, 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 and this. And then √2, bless you, sorry, √2/2, -√2/2. So it looks kind of like this, right? Now, asymptotes will be wherever the curve touches the x-axis or the midline if you vertically shift the graph. And then I have a point here, here, and here, and then I have one at √2, but a -√2 down here, and -√2 down here for the symmetry, and √2. Whoa. And again, if you were to plug something close to pi/2 is like 1.57. So if you're playing like 1.56666669, the y value is going to go haywire, right? It's going to shoot up towards infinity. So that's a portion of it, right? I mean, it's one period, of course. I mean, if you want to keep going, you could do this if you so desire and do more, but this is considered one period because you show one full cycle. So that's cosecant, sorry, that's secant. Questions on the graph? No? Okay. Let me do, I'll keep this graph displayed. Let me do domain range and all the other fun stuff off to the side here. So domain is still all real, except now yeah, you could say except pi/2 plus pi k. Where again k is any integer. You could say that if you want. That works. Or Or you could write this. You could write pi k over 2, where k is any odd integer. I'll leave it up to you, whatever you prefer. We do have to be very explicit as to what's being excluded and what k would hold. Either way, I don't care. Totally fine. Okay, range is still the same as before. Negative infinity to -1. Union 1 to infinity. Periods 2 pi. The vertical asymptotes is x equals pi over 2 plus pi k, where k is any integer, just like the domain part. And the symmetry is even, because it's symmetric about the y-axis. Too good.
It's like this problem like this. Oh, you're doing that. Finally, like, we have to write that down. I still understand the problem.
What would you like for
I would like to know the implications of say it again for the very last notes.
Yeah, well, right. Yeah.
Just say it twice.
Yeah, I mean, if you do shift it though, it does get a little strange. Let's talk about, yes, you would say, but you're not gonna actually, I think you are gonna say, let's do a problem, let's see what happens. Because I'm trying to wrap my head around that, I can't just get inside to a problem, so.
When we can start having shifts and like all the, compressions and stretches. Yeah, let's see what happens.
I was like, should we restate the phrase?
Yeah, of course, right. Okay, guys, move on. Tangent. Okay, tangent's probably, I think, the least favorite because it always seems a little strange how to calculate that. But what we're going to do is we're going to do sine and cosine first, because you guys know this identity, right? Tan theta equals sine over cosine, right? That should make sense, because what coordinate is sine on the unit circle? Y. And what coordinate is cosine on the unit circle? X. And when you're on the unit circle, if you draw a triangle, right? If that's x and that's y, the tangent opposite of adjacent would be y over x, right? So that's what we're going to do here. We're going to use our knowledge of SOHCAHTOA and identities to make sense of all this. So again, this is going to be 0, 0, 0, 1, 1, 1. Nope, -1. My bad. 1, 0, -1, 0, 1. I'll do the division later. Pi over 4, that's √2 over 2, √2 over 2, √2 over 2, but negative √2 over 2. Negative √2 over 2, negative √2 over 2, negative √2 over 2, and positive √2 over 2. Now we divide sine over cosine. Remember, that's sine over cosine as an identity. 0 over 1, of course, is 0. But 1 over 0 is undefined. So it's undefined at these two locations. That's 1 and 1, but -1 and -1. As it should be, because tangent is positive in the first and third quadrants, negative in the second and fourth quadrants. 3 pi over 4 and 5, 7 pi over 4 in the second quadrants, pi over 4, 5 pi over 4 in the first and third quadrants, respectively. We're okay? Can I move on? Yeah, cool. Let's do it. Let's do the graph. Again, I have the table right in front of me. So here's what's going to happen. We're going to do a point at 0, 0, a point at pi over 4, comma 1, and you have your asymptotes here at pi over 2, and the asymptote at 3 pi over 2. And just so things seem complete, I'm going to go to the left side also, negative pi over 2. I can do another cycle if I want, but I think that's fine. You have a point at 0, pi comma 0. You have a point here and here. And negative pi over 4, if you go clockwise, the tangent would be -1 there because you're in the fourth quadrant. And you do the graph. And again, you have the asymptotes because if you were plugging values close to pi over 2, the y value would go haywire. Okay. Domain. Range. Period. Guys, quiet, please. BA. Symmetry. What do you think the range is gonna be here, guys? All real, totally. But a domain, it's every pi over 2. So you're gonna say pi over 2 plus pi k, where k is any integer. And then to your point, Duke, you can just repeat that for the vertical asymptotes. The period's pi, by the way. It takes pi units to complete one cycle. I had 2 cycles here, by the way. This is 2 cycles we did. And the symmetry is odd again, because you rotate about the origin to get back to the same configuration. Okay. Good so far? Yeah. All right. Let's keep moving. Cotan. Okay, close the loop here. Last trig function. We haven't done yet. Okay, let's do this. So you're going to reverse it now. Cotan is cosine theta over sine theta, right? Right, because cotan theta is 1 over tan theta. And tan theta was sine over cosine, so you have to reverse, right? Okay, so let's talk about it. Cosine of 0, 1, negative 1, 1, 0, 0, 0, 0, 0, 1, negative 1. And that kind of sounds like a broken record. Root 2 over 2 over 2 over 2. Negative root 2 over 2, positive root 2 over 2. Both are negative here. But now you guys should become the unit circle. Root 2 over 2, negative root 2 over 2. So you get 0 and 0 here. Undefined here. Undefined here. And undefined here. And also we get 1, negative 1, negative 1, and 1. Okay. So far, okay? All right. Wait for you guys to finish copying the table. Oh, they make mistakes. Sorry.
Yeah, that was wrong.
You are correct. I made a mistake. Thank you. You guys are on it today. Yeah, because I looked at it, I was like, wait, it's supposed to be odd same. Yeah. That you guys saw that. Okay, so now let's do the graph. So here's the deal. We have a vertical asymptote at 0. At pi. So we're going to 2 cycles again, and 2 pi. The pi over 2 comma 0, x-intercepts will be pi over 2, 1, and negative 1, 1, and negative 1. So it looks like tangent has the same curvature, but it's reversed. It's also a decreasing function. And just so you know,
This is incredibly important you guys have this really solid, because by this time next year, you'll be doing derivatives, as like slopes of tangent lines and custom, you're gonna be applying calculus principles, right? Maybe in spring you might introduce this, but you have to have this, image in your head, right? You have to know how these graphs look.
you'd be good.
So is this different from like the negative tangent plus power?
Yeah, because it's shift. No, it's actually the same thing. It's the same thing because you're using identity. It's the same thing. Yeah, that's good. Yeah. So what Yuvi just did, he shifted the graph as he would between tangent and cotangent. So then he also did a reflection because we have to have the reflect. Yeah, because that's part of that, because it's not a function, right? Because tan negative theta is negative tan theta, right? But also you do a shift also.
Yeah.
Yeah. So that's good. I like that. Anyway, domain. All real. Except this guy's gonna say pi k, where k is any integer. Range is all real. Again. Period is pi. The VA is x equals pi k. The symmetry is odd, right? Oh, and you have to say k is an integer, duh. Okay, we're good? All right. Okay, that's the boring stuff. Let's do the fun stuff. Let's do where we start changing things around. All right, let me clear. So I think we totally finished these notes today. I feel very confident about that. So I'm going to rewrite this y equals 2 times tan bracket 1/2 x plus. What are you going to put inside? 2 pi. Thank you. 2 pi. Yes. You divide it by 1/2, which is multiplied by 2. Okay. So let's kind of figure things out here. A is 2. That does kind of matter, that a value. It does matter. It's not quite an amplitude, but it does matter. And generally speaking, we have y equals a times tangent b x minus h plus k. And the period, of course, is pi over b. So my period, of course, is going to be 2 pi. Pi over b. Pi over b. Not 2 pi over b.
Tangent, right? Here's pi for a parent, right?
Yeah, good. I'm glad we caught that. H is negative 2 pi.
It's power B, I guess, for like.
Because the period is pi for the parent function. Yeah, right? Okay. All right. Okay, so let's do this, guys. So we have negative 2 pi. Let me think this through here. Yeah, negative 2 pi is going to be in the middle. We're going to do 2 cycles, by the way. Okay. So the middle is negative 2 pi, right? And the asymptotes are here and here. Now, what you could do, if you so desire, is you could set the inside equal to negative pi over 2 to get the starting point, which would be x plus 2 pi equals negative pi. See, I just did that. I was able to determine my asymptotes by setting this equal to negative, excuse me, set equal to negative pi over 2. Because on the parent function, wasn't the asymptote on negative pi over 2, right? Where was the other asymptote on the parent function? So I can do the same thing. Or once you know the period, add 2 pi. So even though the shift is negative 2 pi, that's just the middle of the graph, right? That's not the asymptote. So you got to be mindful about that. Or you could think about it, if this is the middle of the graph, right? This width has to be pi. So you have to, this width has to be 2 pi. So then you can just go pi in each direction. That works too, if you want to think of it that way. But this will be the starting point. This is like how you start it. And I know it's going to end at negative pi because that's period 2 pi. Now, here's what you do. Here's how you could partition if you want, but you're going to drive yourself a little nuts if you try. I mean, it's negative 3 pi over 2, negative 5 pi over 2. You can plug it in. But personally, what we could do is we could just think about the a value, right? It's a vertical stretch. So the parent function doesn't get stretched, right? It's just that 1 and negative 1. But this gets stretched by what factor? Yeah, it's a vertical stretch, right? And the curve is generally supposed to go like this. What if they were negative, by the way? What would happen to that curve? It reflect about the x-axis, but we don't have to deal with that for this one. So I'm going to put a dot right here and a dot right here. So I've taken care of the stretch. And I deliberately, partition 2 more times, right? To have the proper symmetry. I know it's not the best looking graph, but there you go. And if I do another cycle, another asymptote pi, show the stretch. That's a little better. So, yeah. So I think we're good here. Makes sense. Vertical shift was 0. Horizontal shift was -2 pi. The vertical stretch was 2. The period was 2 pi. I think I got all that right. Yep. Okay. So that makes sense. We're good. Okay. Why don't you guys try the next example? See how it goes. I'm also going to kind of figure out what your homework's going to be because I might have to adjust a little bit. Yeah, go and try that one. See how it goes, and I'll check in about 3 or 4 minutes. Do good.
Well, sorry.
Yeah,
This is what we do.
You have to do periods.
It's already on the last block, I can just relate it to them if I wanted to.
No, I would have to do as much.
The code down is like negative.
I'm proud. Oh, wait,
All right.
Really dropped it there.
He just said it. It looks like almost this straight.
Dropped it there.
Well, you can make it wider though.
Maybe that's wrong. Maybe that's wrong. That's wrong.
Don't be playing.
Moved it down. So, it should be down.
Let's see how we did. It's okay if it's ugly. Ugly's okay. As long as it's accurate. All right, here we go, guys. Let's do this.
No, I think
It's not zero.
That's actually so true.
No way he's stronger than stronger than you. This guy just said that Kosher was stronger.
Yeah, good. You factor it out first. Actually, no, you do the vertical, you do the horizontal shift first, and you reflect afterwards. Because it's the process of undo. If you set equal to something, you would, if you had like -2x + 1, you'd subtract 1 first, right? Yeah. Okay. The amplitude here is 3, so we have to go 3 higher and 3 lower. Okay. Yeah, my graph's not gonna look great either, guys. Don't worry.
It's gonna be very nice. The gross was
Okay, need steady hands here. That's why I didn't become a surgeon. Okay. Yeah, not the best. I did my best though. Anyway. Okay. Anyway, vertical stretch is 3. No horizontal shift. I know. Thanks. Period I got. And vertical shift. So vertical stretch, my bad. And vertical shift. Down one. Yeah. Okay, we got time for one more. It's the last one for today. And I feel good. That means we're all on pace. Okay, guys, quiet please. Let's finish strong here. Y equals 1/2 secant. Okay, so guys, factor out that 2 first, okay? Okay, what's inside when we factor out the 2? Thank you. Plus 3, okay. So graph it like cosine first. That's what I do. So you're gonna start it. You can start at pi over 2. We'll put pi over 2 right here. You're gonna end it because your period is what? Your period's pi here, right? And your a is 1/2. And the vertical shift, the k value is 3. So 1, 2, 3, and I'll do 4 for good measure. Okay. And we'll do a midline right here. Since the period's pi, it's gonna end at 3 pi over 2. Yep. So halfway between pi. And if you do like a cosine graph, it's going to start at its peak, which is going to be 1/2 above 3. And then you get down to, and we have 2 more partitions. But this is secant. So we're across the middle. And you draw your curves like this. So you use the green curve as a crutch. And then you can erase it afterwards. Questions? Do you have a question?
I feel like I did this sort of thing afterwards, but like, I didn't do this sort of
Zero pi. Go to the next shift.
yeah, but I shifted it, but I just threw it from 0 to pi. Like, does it still make you that pi is
Okay, as long as you have the low point, I would do.
I just didn't do like I didn't shift.
You need to make sure you understand.
Yeah, I just like I didn't
Okay, guys, we're all done for today. We have about 2
to 3 more minutes left. So homework's on the board.
I'll put it in Schoology. Remember the rest of it. There's 5 problems, 38, 40, 48, 47, 48. If you have an answer for that one, I'll put those once you check how you're doing. 5 problems. I figured she'd take it about 20.
Yeah, I mean, I'll get.